So now let's look at some examples of these. So in this first one, it says that triangle DEF, in triangle DEF, DE is congruent to DF, and I can already see that from these tick marks. So I know that this side is congruent to this side. I want to name two congruent angles. Well, I know from my base angles theorem that the angles opposite of my congruent sides are going to be congruent. So if I go to the angle opposite of FD, that's going to be angle E, and it's going to be congruent to the angle opposite of ED. Well, that's just going to be angle F. Okay, now let's look at one that's a little bit harder to see. So I want to complete this statement, and I have this big triangle, but I also see there's two triangles that make up that big triangle. So for the first one, it says if HG is congruent to HK, then which two angles are congruent? Okay, well HG, that's right here, is congruent to HK, which is right here. And so again, I know by my base angles theorem that the angles opposite of it are also going to be congruent. So I know that this angle is going to be congruent to this angle. So this angle, I can go ahead and just call it angle G, that's fine, or I can do HGK. Let's go ahead and do that. And then for this angle, remember when I'm naming an angle, the vertex needs to be in the middle, so I can call this HKG. I could have switched the G and the H, that's fine, but the K needs to be in the middle as well as this G. Okay, now I'm going it from the opposite way. This says if angle KHJ, so KHJ, so again that middle letter means my vertex, that's this angle right there, is congruent to KJH, so KJH, it's going to be that one right there, then what two sides are congruent? Well, again, I know from the converse of the base angles theorem that the sides opposite of my congruent angles are going to be congruent. And so if I look at the side opposite of this angle KJH, that's going to be this side, so HK. And if I look at the side opposite of my angle KJH, that's going to be this side right here. So that's going to be KJ. Okay, now let's actually do some solving. So this one says to find the measure of angle G. So first off, I notice that I have that these two sides are congruent. And so automatically I know by the base angles theorem that the angles opposite of them are also congruent. So that means the angle opposite of this one, so G, is congruent to the angle opposite of this side, which is J. Well, angle G, so yeah, angle G is congruent to angle J. Well, angle G is just x plus 44. Angle J is 3x. And so now I just need to solve for x, so go ahead and subtract x from both sides. And then divide by 2. So we get that 22 is equal to x. But now I actually need to find the measure of angle G. So I'm just going to plug in 22 for x. So I get 22 plus 44. And so that means that the measure of angle G is going to equal to 66 degrees. Okay, go ahead and pause the video. I want you to try and do that same process with number 4. So the answer you should have gotten here was 48 degrees. I know by the converse of, by the base angles theorem that the angles opposite of those congruent sides are congruent. So all I did was set 6y equal to 8y minus 16, and when I solved for y, I got 8. And then I plugged in 8 for y and for measure of angle n, and I got 48. Okay, that is it for today. If you want to look at some extra examples, those are linked below. Otherwise, you can go ahead and get started on that homework assignment. I hope you all have a great day.